Hi students, today we will learn about 1, 2 cc disconnections. The disconnection is labeled 1, 2 cc because the new bond is forming two atoms away from the functional group. This is similar to 1, 2 CX disconnection. The only difference is that there we had a hetero atom and here we are disconnecting a bond between two carbon atoms. First, we will learn about synthesis of alcohols. The epoxide route works very well. So let us take one example. So here we have a target molecule 1. So here you can see how we have an alcohol here as a target molecule. Alcohol is a function group here. And we are going to start numbering the carbon bearing the hydroxyl group as 1 and the adjacent carbon as 2. Now, since we're going to disconnect after the second carbon atom, that is bond between carbon 2 and carbon 3 is broken. So hence it is called as 1, 2 CC disconnection. That is after the second carbon we are breaking the bond. So hence one carbon is having the hydroxyl and the second carbon is adjacent to the carbon having the hydroxyl, and after the carbon 2 we are disconnecting. So hence it is called 1, 2 disconnection. Now after we disconnect, that is do the 1, 2 disconnection, on the retrosynthetic arrow we are going to write down as 1, 2 CC. Now next is going to be the writing the synthons. Now the synthons, as we know that we can give a positive charge to the carbon 2. And when we give a positive charge to carbon 2, we know that it is following the reversal of polarity, since carbon 2 should have had a negative charge, but since here we are giving a positive charge, the synthetic equivalent of that would be an epoxide, which is a very good starting material. So hence we make use of this along in this mechanism. And the other synthon is going to have a is going to be an anion, and the synthetic equivalent for the anion would be a Grignard reagent. That is, we're going to have CH3CH2 MgBr as one of the synthetic equivalent, and the other synthetic equivalent is going to be an epoxide. So these two are going to be the starting materials to prepare this target molecule 1. So here what we're going to do is, first we are, see this Grignard reagent, we cannot use it as a starting material. So what we do is we are going to further divide it as an alkyl bromide. So here we're going to use alkyl bromide as starting material, and on reaction with magnesium in presence of diethyl ether, because diethyl ether works as a good catalyst, and here it is one reagent which can bring about a Grignard reaction. So Grignard reagent. So hence we are going to make use of diethyl ether and magnesium, and in presence of an epoxide, it is going to give rise to the target molecule 1. So this is how you can write the synthesis. If you want, you can also split this reaction synthesis and write down first would be an alkyl bromide reacting with magnesium, and diethyl ether is going to give rise to an Grignard reagent, and this on reaction with an epoxide gives rise to the target molecule. Even this way you can write down the synthesis. So this is going to be a general mechanism for all the target molecules which have the alcohol, and whenever you're looking for a 1,2 disconnection, it would always give rise to epoxide. And when epoxides are unsubstituted, it is very good used as a starting material, and hence we prefer writing down epoxide as synthetic equivalent whenever you come across an synthon as this kind. Next example is again a similar example, just that I have given more and more examples, but they are all having the same kind of disconnection. So here again you can see how there is an alcohol in the target molecule, and it is again we're going to do the 1, 2 disconnection. Always start labeling the target molecule first, and then numbering the target molecule first, and then you can do the disconnection. So now here we are going to give one carbon number 1 to the carbon having the hydroxyl, and then the adjacent carbon towards the phenyl group. The next process would be writing down the synthons. So here you can again always you can make sure that the carbon 2 is given a positive charge, and the other synthon is going to have an anion that is a negative charge, and the synthetic equivalent of pH minus would be pH MgBr, a Grignard reagent, and the other cationic synthon would have an epoxide as the synthetic equivalent. Now at this stage, what you can also do is you can make use of a further disconnection of epoxide to an alkenes. So here you have already studied peroxy acid, that is in third semester in free radicals reaction. You had studied the free radical synthesis of peroxy acid, how we can do the analysis, that is nothing but how we can do the homolytic cleavage of peroxy acid. So here we are going to use peroxy acid reacting with an alkene to give rise to an epoxide. So hence what you can do is further you can disconnect an epoxide to an alkene, and you can use alkene as starting material, and see here how we are making use of the peroxy acid, that is RCO3H. That is an alkene reacting with a peroxy acid is going to give rise to an epoxide. So this is how you can further disconnect an epoxide. And this epoxide on reacting with the Grignard reagent is going to give rise to the target molecule 2. So this is how we can write down the synthesis for this molecule. Now let us go to the next example, target molecule 3. Here you have a ketone. You have a carbonyl group. So carbonyl group can be directly, you can do the disconnection 1,1 cc disconnection, or also you can make use of 1,2 cc disconnection for a carbonyl. And also the another approach is you can do the function group interconversion of a ketone to an alcohol, as in this example. So what you're going to do is you can write down the FGI, function group interconversion, and below that you're going to write down the oxidation. There's nothing but alcohol and oxidation is going to give rise to ketone. So once you write down the FGI and oxidation, the next step would be nothing but conversion of a ketone to an alcohol. So you're going to write down an alcohol. From a ketone, you're going to write down an alcohol. Now from this step, it is going to be the usual step, that is 1,2 cc disconnection. Start numbering the intermediate, and then also show the disconnection, that is after this carbon 2 you're going to show the disconnection. Now the synthons for this would be R prime minus and a cation. So the cation synthon is nothing but an epoxide, and for R minus it is going to be a Grignard reagent. So Grignard reagent and an epoxide would be the starting materials. Now you're going to make use of these starting materials, and you're going to write down the synthesis in a similar way like a previous example. Now we have another example here. So here we have an acid in the target molecule. This again you can make use of direct disconnection of CO2H, that is an acid group, or else you can either interconvert the acid to an alcohol. So here what you should remember is always CH2OH on oxidation is giving rise to carboxylic acid. So always remember to write down another extra carbon atom whenever you are going to write down the function group interconversion of an carboxylic acid. So this means that CH2OH on oxidation is going to give rise to an carboxylic acid. This is the meaning. So now once you write down the intermediate in this kind, this again follows the 1,2 cc disconnection. So here you can see how you have numbered 1 and 2 to the carbon atoms, and next to the carbon 2 you're disconnecting. So hence it becomes 1,2 cc disconnection. Now after writing the 1,2 cc disconnection, the next step is writing down the synthons. So the synthons would be an anion and a cation. So the corresponding synthetic equivalents would be an Grignard reagent and an epoxide. So again you're going to follow the same synthesis, and we are going to write down the synthesis, and we're going to write down the target molecule 4 as the final product. So this is how you can make use of. So silver oxide is an oxidizing agent, so it converts the alcoholic group to the carboxylic acid group. So hence this can be, you can make use of this reagent whenever you write down the conversion for alcohol to carboxylic acid. So this is how you can write down the synthesis for target molecule 4. Now the next example is again a similar kind of example. So here we have an ether. So the first step would be you can disconnect the bond between ether and the carbon. Okay, so once you disconnect, you're going to get two synthetic equivalents. That is nothing but both are going to have an alcohol group, because see, once you disconnect, it is going to have a carbon is going to bear a positive charge and oxygen is going to have a negative charge, because oxygen is more electronegative, and the synthon for an oxide anion is going to be alcohol OH, and the other part, that is the cation, would have an OH minus attacking the electrophile, and hence you would get a alcohol. So in both the synthetic equivalents would be an alcohol. Now the next step would be further disconnection of two. So here I've written down as intermediate 1 and 2, product 1 and product 2. And here the further disconnection of 2, that is you can do the 1 comma 2 CC disconnection, would again give rise to an, here it is going to give rise to an amine and an epoxide. So now you can make sure that these two would be the starting material for the formation of compound 2. Now in the meanwhile, we can also do the disconnection for 1, and this disconnection would be 1 comma 1 CC disconnection. So you're going to disconnect just after the carbon atom, just beside the phenyl group, and it is going to give rise to two synthons again. You can see how there is a there would be a carbon having a positive charge which is attached to an alcohol, and that synthetic equivalent would be a ketone, and the other synthetic equivalent would be a Grignard reagent. So these two are going to be the Grignard reagent. Now here you can see that how there is an acyl group that is linked to the aromatic ring, benzene, and you can easily make use of Friedel-Crafts acylation. That is, you can disconnect the benzene with and the acyl group. Okay, you can disconnect benzene and acyl group, and you can write down the chlorobenzene as starting material. So these would be the starting material, that is chlorobenzene and an epoxide, and the amine would be the starting material. Now let us write down the synthesis. So first we have the alkyl, that we have the benzyl chloride. So here there's chlorobenzene, and here we are going to make use of reagents, that is AlCl3 aluminum chloride, which is a Lewis acid, and we're going to make use of the acyl chloride. And this would give rise to nothing but the acyl group which is attached to the benzene ring. So this would be the product. Now this on reaction with the Grignard reagent would give rise to a product 1 that is similar to, that's what I've written here in the target molecule 1. So this is first part. Now the second part would be reaction of an amine with epoxide is going to give rise to product 2. Now you have product 1, you have product 2, and these two on reaction with SOCl2 is going to give rise to nothing but, you have product 2, and this on reaction with SOCl2 is going to give rise to a chlorine which is attached to the aromatic ring, that's the amine, which is nothing but, and sorry, this with reaction with 1, that is these two on reaction with sodium hydride is going to give rise to the target molecule 1. Target molecule 5. So this is how you can write down the synthesis. See, whenever you have a larger target molecule, you can go on writing down the fragments, and the synthesis also you can write it in 2 parts rather than getting confused. So this is how you can make use of the writing down synthesis for a larger target molecule. And the last example, that is target molecule 6. So here also we have an alcohol, and you can directly disconnect the 1,2 disconnection. You can make use of 1, 2 CC disconnection, and you can write down the fragments. So now after writing down the fragments, so you can further disconnect the alcoholic group. Further you can disconnect, and you can write down as, again you can make use of 1, 1 CC disconnection, and you can write down the Grignard reagent, and the disconnection of this fragment would give rise to an aldehyde. This aldehyde and the Grignard reagent would be the starting materials, and you can make use of the writing down. See here, once you write down the starting materials as the alkyl bromide and magnesium in presence of the aldehyde, you're going to get an intermediate. Now this on reaction with hydrogen bromide in presence of sulfuric acid is going, because here we want a bromide group to get inserted here in this intermediate. So hence we're going to make use of sulfuric acid and hydrogen bromide, and you're going to get an intermediate of this kind, and this on further reaction with the magnesium and diethyl ether and in presence of an epoxide is going to give rise to target molecule 6. So this is how you can write down the reaction for synthesis for this kind of a target molecule. Okay, so this ends 1, 2 CC disconnection for alcohols. Thank you very much.